Hi everybody, in this video we're going to learn a lot about content delivery networks, also known as a CDN. And don't worry, this video does not assume you know a whole lot about networking or how the internet works and things like that. The goal really is to help you understand from a very basic level by using some real-world examples and then tying it closer and closer to our goal of explaining how a CDN is used in our everyday life as people who either build websites or browse websites, which is probably all of us. And so let's get started. So a CDN, which is really a short way of saying content delivery network, is something that almost all of our favorite websites use. And the reason they use it is because they use it to ensure we get content to you really quickly. And the way it works is a bit mysterious at first, but we're going to look at some examples to kind of highlight what some of the challenges are in getting content from where a website has it to where you are right now, and what are some techniques that we can automatically figure out to help simplify that going forward. So I'm going to use an example that many of us are probably very familiar with, and that is ordering pizza. Now, let's imagine that you live right here. You live in this area where you can see there's a little umbrella kind of indicating where you live. There's some roads that kind of connect all the various places together. So it's not a very difficult to reach area. It's just part of a location in a community, in a map, and all of these things. Now, let's say they want to order from, you decide to order pizza. And where you're ordering pizza from is not a chain. It's a particular place you really like. It's a mom and pop store, and they have a single location here that is perfect for you. Okay, now you order from them and they're about to deliver it to where you go. The time it takes to deliver the pizza to you, multiple factors go into it, of course, but the biggest one is distance. How far away are they from where you are? So when they get the order and make it delivered to you, the distance they need to travel plays a big role. The closer you are to the pizza place, the faster the delivery will be and the faster you'll be able to enjoy your food. Now, the opposite also holds true. Let's say you are further away, like in the stadium that is on the other side of this bridge and further away from where you live. If you still want to order from this single pizza chain, or pizza, mom and pop store that's really good, then you have a longer distance to travel, and it's going to take you longer for your pizza to be delivered. So the distance definitely plays a role here. And if you go even further away, there is more distance you need to cover, so you can imagine the time it takes will be much greater. Now, the thing is, with greater distance, there's always the risk of other factors that will affect how quickly your pizza gets delivered. We're assuming a world where there's no traffic, there's no construction slowdowns, or animals crossing the street, or weather, or accidents, and a bunch of other things that can get in the way between you being able to enjoy what is being delivered. So that's definitely a factor to consider, which only increases the longer you have to travel to get something. Now, let's say we change our plan a bit. You want to order pizza and you have a coupon from a chain, and as always, it's due right now. And so you want to order some pizza very quickly. Now in this case, unlike our mom and pop store, this chain has multiple locations throughout the city, in many locations. You can see that, we live where the umbrella is. There's a couple of chains nearby. And in the other locations that we kind of looked at earlier, there's a chain nearby as well. So if we had to order from a chain, here's how the behavior will be a little different. Now, in this case, if you're going to order, you have more choices for a shorter trip. If you're ordering from the stadium, or in this case, the office building, instead of earlier where the pizza had to be delivered from a central location and had to have a long journey to get to where you need to be delivered, in this case, it's a more nearby location. So the distance between you ordering the pizza and getting it to you is very quick. And the advantage of having multiple locations is that you're less likely to be impacted by all those situations we came up with, like construction and other delays. A flood of orders suddenly comes into a closest store. That's okay. You have other locations that can help balance the extra demand. Or if a power outage takes some of these locations offline, the chain can be optimized, the pizza chain can optimize to get all deliveries and all orders from another location. And so the end result is you have more backups, more fallback plans to be able to still ensure that if you want pizza, you can get it very quickly without too many unforeseen delays. And this means that, here's an example where two of the chains closest to where we live are offline. Could have been a power outage, could have been something else. And you can even find creative ways for them to get it delivered where they can, potentially use a boat. And I'm using this as like being a little, exaggerating here on terms of it. But the thing to highlight is that by having more options and more backups, the more ability you have in being able to achieve the pizza delivery that you really want without having to worry about unforeseen things just completely preventing you from being able to have this. Now, pizza's great. It makes sense. Yep, you order pizza. Closer you are, better. The further away, it's more tricky. Now, how does it relate to content delivery networks and CDNs that we are really here to learn more about? And here's where it really kind of comes into play. So to summarize the 3 big takeaways from what we just saw, one pizza location wasn't really great from a delivery point of view, and especially if you live further away, it definitely wasn't great. By having multiple locations, the mega pizza chain was able to rely on the closest location and get a pizza to you very quickly. Now, unforeseen problems are also reduced with multiple locations. We talked about all the various things that could come up that makes it very difficult for a single location to reliably be able to give you pizza. By having many locations, we reduce some of them. Now, the same kind of an approach can be applied to our content and our websites. So let's say we have a web server. A web server is basically a machine that is serving web content to your browser. So if you go to yahoo.com or google.com, does anyone go to yahoo.com these days? I don't know. That'd be a good research study to do at some point. But when someone visits a website, that content is served them somewhere, and that somewhere is typically a web server, basically a giant file system and disk and some, web request related APIs that send data to the browser. Now, the way a web server works is that, let's say my web server is on the West Coast. It's somewhere in California, and I want to access it somewhere in the East Coast. The way a web server typically works is that when it sends data, it doesn't send it to you directly the way internet typically works. There are multiple hops involved where it goes from, I have an approximate idea of where your computer is, to getting more precise with each hop as it gets closer to ultimately hitting your particular device, your phone, your laptop, your desktop, your smart fridge or TV, a variety of different devices. Now, the thing is that each network hop adds a slight amount of delay as part of getting the communication between a web server and your visitor's device really going. And this is where the distance between a web server and a visitor really matters. Similar to the pizza example, the further away a web server is geographically from someone who requests our site's content, the more network hops are needed to make the communication work. So you can imagine that you have to, just like in real life, right? If you had to jump, from one place to another, the closer something is, the fewer jumps you have to make. And if it's something really across the room, you probably jump like multiple times to get there. Just standard, sack race rules in many ways. The greater the network hops, the greater the delay. The fewer the network hops, fewer the delay, or the smaller the delay amount. Now, let's imagine broader. We talked about what it's like to go from the West Coast to the East Coast, but what if you had to go worldwide? What if your web server is now responsible for serving content to visitors all around the world? Can you imagine the amount of hops it would take? So in this case, I'm somewhere, I guess server's like in India. That's a lot of distance to cover, it's a lot of hops to make. And similarly, if you're closer by, you have fewer hops. So you can imagine that this distance would take a long time to cover, and the distance right here would take less time to cover. Now, the thing we've been focusing on is really distance as a major contributor to how long it will take for something to load, but there are other factors at play as well. The quality of the networks the data will travel through will vary. This is the digital equivalent of a traffic jam or a cable interruption or an accident or animals crossing the street. I don't know what the digital equivalent of that would be, but there are always delays. There may be network congestion in some part of the world, and underwater cable, which are often used to transmit data really quickly across large distances, might be broken, or a slow cell phone connection somewhere, or someone is hacking a server and there's a DDoS attack which prevents network requests from going through reliably. A variety of different things can come in as well. And so the old pizza type of rule applies here. The greater the distance our data has to travel, the more things will come up that increase how long it will take for a visitor to access our website's content. Not really great. And the thing is, why do we care? Why do we care about some of this, right? At a certain level, we know that a faster it takes for your content to be served, the less time someone has to wait for our content. And, I'll share these links in the article that I wrote for what a CDN is, where you can see more about this. But there have been studies after studies that have shown that the less a person has to wait, the more responsive your website is to when an action a person is performing, the better it is overall. And this better could be if you're an e-commerce site, more people buying and shopping your content. Or if it's a typical content site, the more time people spend in terms of engaging with what you are providing and so on. There's a lot of little details that have been studied over the years on why it's good to have really fast performance. And so the goal really is this. Our users are going to be worldwide, and we want to make sure that it doesn't matter where they are in the world, we want to give them as fast of an access to our content as possible. And that's really where CDNs come in, CDNs to the rescue. So the problem right now is this. Our web server is located in one part of the world, and it is responsible for serving visitors from all parts of the world. It's similar to the mom and pop single pizza chain, or a store that now has to serve food pizza for the entire city, no matter how far away some of the people might be. Now, what if we had a way to replicate our web server to more parts of the world, so more visitors are physically closer to it, so the distance would not be as large as it is for some people? What if you had something like this, where you have a web server in different parts of the world where it can serve content for those local visitors more quickly? Now, replicating a web server itself multiple times sounds kind of cool, but some technical issues. You don't want to have, one server that now has to be duplicated everywhere, and then you're, figuring out which one to serve files to and all of that. It's theoretically possible, and some ideas that we're going to talk about or smell and look similar to it, but it's not actually what we're going to do. We don't want to have a web server replicated in multiple places. What if instead we could have a very similar solution where we still have a single web server, a single place where we make all of our updates to, we make all of our, pull requests, and, we make all of our configuration changes on a single location, but we still have a way to give users the content they need from more local location. So thus avoiding these long communication times, best of both worlds. Our world is simpler because they have one web server. Our visitors' lives are better because they have easier access and faster access to the same content. And this is where CDN comes in, again, short for Content Delivery Network, where it acts as an intermediary between a web server, and oftentimes you might see our web server referred to as an origin server, the source of truth for the content, and our visitors spread across the entire world. So imagine we have a model like this. Here you can still see we still have only a single web server. If you look at it in California, this little yellow circle, our web server is still there. But what we now have are individual nodes throughout the world that are connected to our web server. And those nodes are responsible for directly sending content to our end users. And oftentimes these nodes are known as edge servers. The edge, they're basically the ones that are the last frontier between the content you want and the content that's actually being stored by a place that can give it to you. And so these, these little gear icons really are what are the CDNs, the content delivery networks, who mediate between our web server and our visitor and provide that really fast access to all of our content. So the way you can imagine it is this. Let's say we don't have a CDN. We're in a world where there's no CDN involved, and I'm just, a web server that is sending content all around the world directly from my one location, the single pizza mom and pop store serving the entire country in some ways. And I want to request a file called index.html from foo.com. The workflow would typically look like this. I'm the visitor. I type in my browser foo.com/index.html. The first thing it does is we go to a DNS server. Now, I don't get too hung up on what DNS servers are right now in this video, but imagine it's like a gigantic phone book where it knows that you're looking for foo.com. I know exactly where foo.com is. Here's the way to get to the server that contains that information. So the DNS server routes me appropriately to foo.com, the web server that contains the data. And then the web server is like, cool, you are asking for index.html. I'm going to send index.html directly to you. And so you can see there's a little cycle where I ask the DNS server, tell me where foo.com is. The web server is then notified, and then the web server sends me the information. This is a world without a CDN where the main players really are you and the web server itself, and of course a DNS server also. Now let's say that you do have a CDN. In this case, you have a CDN and you want to be able to rely on it for sending the information. Now in this case, we call foo.com index.html just like before, and we go to the DNS server and say, hey, I want to go to figure out foo.com and get this information. In this case, instead of foo.com going directly to a web server, it goes to the CDN. The CDN is now told to be the primary recipient of all requests that need to go to foo.com, which have normally been handled by a web server. And it says, okay, I'm fetching index.html. The very first time the CDN is asked for index.html, it's going to go, oops, I don't have it. I don't have it, cached. I don't have it downloaded in my local repository. So let me go and talk to the web server and get a version of index.html so that I can keep it for myself. And once it does that, then it can go, okay, I'm going to send it back to the visitor that originally requested it. So for the very first time where the content is not cached, our CDN is still the primary face for the web content we're requesting, but it knows about a web server and it gets the data just the first time around. Now, what this means is that in subsequent requests, let's say someone is asking from the same region, is asking for index.html from foo.com a second time around. What happens this time is that, same workflow, the DNS server is like, yep, the CDN is the one that's responsible for requesting or intercepting all requests from foo.com. And this guy's going to go, okay, you want index.html? Great. I already have it. I'm going to send it to you immediately. That whole round tripping where it goes from where I am, where the CDN needs to talk to the web server, that is completely skipped over. So right now I have a very fast path where the CDN is the primary interface for being able to serve index.html. Really quick, really, really fast. Now, when it comes to CDNs, the biggest benefits they provide are with static files, like those of our HTML, CSS, JavaScript, and images. The first time around, the CDN will get it from our web server, but then we'll cache them, and it will keep them in its cache, so that way anyone who asks for it will get it very, very quickly. And it will periodically check with the web server, based entirely on what you configure the CDN to do, to make sure the latest version is often cached. And if you tend to be updating an image very, very frequently, you might tell your CDN to proactively check for updates from the web server more frequently as well. Otherwise, people might get a stale copy of your content. Now, when it comes to dynamic content, a lot of the content we create isn't static. It's not images. It could be things like you're passing some data, you're calling some serverless function somewhere, like something from AWS Lambda or Google Cloud Functions or Firebase Functions. You might find yourself in a situation where the data is going to be varying every time, and you can't really cache it because each time is going to be very unique. So if your site has a lot of dynamically generated content, then a CDN may not help you as much as it would as if your site had a lot of static content. So just keep that in mind if you think your CDN is going to solve all of the delays you might have in experiencing and getting data to it. But what CDNs can ultimately do is they not only bring with you extra performance in terms of faster response times between a web server asking for data, they often tend to have extra security. They have a lot of capabilities to prevent DDoS attacks and other things that would be very tricky to do at small scale on your own web server. They lower bandwidth costs because you're not the data is not traveling long distances. Your content is often smaller because CDNs do a great job, if you configure it properly, to compress the data deeper, to dynamically change the image formats oftentimes. Like if you think that everyone is going to be getting a PNG file, a CDN can go like, well, these users can actually benefit from a WebP version or an AVIF file, and then be able to serve that directly without you having to make any modifications on your web code itself. And they also have minimal downtime because you have essentially, just like the pizza chain, you have many, many places that people can order your food from. Then it makes it easier for if one CDN were to go down, or if even your web server were to go down, there are enough cached copies floating around the world that they can still get data. Might not be fastest, might not be the most fresh, up to date, but it's definitely better than giving them a website not found or 404 or any of the other error codes that kind of make people lose trust in the content that you are building. And before we start getting closer to wrapping up, this site uses a CDN quite extensively. That site gets a lot of traffic, and so and it's a worldwide traffic as well. And so the CDN I use is Cloudflare. And here's some examples from the dashboards they provided in terms of what benefits a CDN has provided for the site's visitors overall. You can kind of see that if there was no CDN, the average response time would be about 480 milliseconds, about half a second. But because there is a CDN involved, you can see that the average response time is only about 211 milliseconds, which is really great. And for many of you with really fast connections, this site will connect to you if you do like a trace route or a ping within a few milliseconds, like under 10 milliseconds. So, performance is something I take very seriously, and a CDN has helped take care of a lot of the performance issues caused by just network delays and large distances and so on. And you can kind of see just approximately based on the quality of the networks around the world, the percentage of improvements they've often seen, or which regions gain the most benefit. And it's understandable in many ways because the web servers for this site are located primarily in San Francisco and California, but there are a few for the forums that are actually on the East Coast, just for various reasons. And you can see that how the CDN has helped improve the performance in general across all these areas. And you can see, ironically, the biggest gain has really been in the Midwest and the Northwest, in the Seattle area, which just happens to be where I am right now. And one additional detail is that, because I'm using Cloudflare, each CDN has their own extra bells and whistles they provide, but I have Cloudflare actually optimizing images in real time as they're being requested and caching them. And you can see that, the image optimizations they provide are, SVGs, WebPs, it serves about 18% of the time, even though I specified 0 WebP images in my source or created 0 WebP images, it automatically did it dynamically. So it's kind of cool to see that 18% of users were able to get a faster, smaller image than they would have otherwise if I didn't have a CDN involved at all. Now, the last thing is, do you need a CDN? Is it something that you would really benefit from? The main thing to take away is that CDNs won't magically solve all of your site's performance problems. There's a boatload of things that happen between someone requesting some content on your site and the first pixel being painted on screen. We talked earlier about some of the work on the Core Web Vitals or the Lighthouse scores or even WebHint in terms of being able to analyze your site for performance issues, render blocking CSS, JavaScript that's doing too much, and improper use of CSS properties that cause layout shifts, that cause performance degradation. Those are all things that a CDN will not solve. Those are things that your code needs to be addressing, needs to be fixing, needs to constantly be, doing better than it was doing before. But what a CDN will solve, though, is I'm requesting data from a server. That server takes a long time to get back to me with the response. So if you control that server, you can put it behind a CDN, and you'll be able to at least reduce those things. And CDNs provide other capabilities that we saw earlier in terms of better security and better image optimization and other little bells and whistles that can also help solve some of these problems. So there you have it. A very quick overview of what CDNs are. Still only scratching the surface. We didn't go into great detail about the internals of a CDN or how the DNS routing works or some of the optimizations in the headers and requests they make to see how they actually make the caching and storing work. The main thing to keep in mind is that a CDN is in many ways just a replica of your web server, and oftentimes a slightly stale replica of your web server if your content changes very frequently, but it's only stale for the first request. After the first request, when someone had to pay the extra cost of getting the data from the web server and storing it in a CDN, it is lightning fast on all subsequent requests until you decide that it's time for the CDNs to refresh and pull fresh content just so they update their stored data. So, a lot of fun. If you think you might need one, there's a lot of great CDNs out there. Highly encourage you to use them. If you need any help learning more about CDNs or just how the internet works or any other web development topic, post in the forums at format@crypto.com where I and others will be happy to help you out. Tell your friends and enemies all about it. Hit subscribe to be notified of other videos that I'll be making that are similar to this, oftentimes dealing with web development and coding topics, and sometimes dealing with more high-level topics as fundamentals, how the web works. Follow me at Krupa at Twitter to see more bite-sized updates on what I'm doing, and in other networks where you might see, at Krupa and my profile picture, so that way it's the right Krupa as opposed to, some other fake Krupa. And lastly, if you enjoy watching videos, if you enjoy reading content online, you might also enjoy reading content in book form, where we have everything in paperback editions, where you can physically see something in pages, and you can flip the pages, you can smell the dead wood that made up the paper in the pages. There's a lot of cool things you can do. So check out my books, link below. And with that, I will see you all next time.